here is a quick update on the robot. So I have everything, all the 3D printed components, all the main sensors, motors, that type of thing, fully put together on the robot. I'm just currently in the process of getting it all interfaced together through software. When it's completed, I'm going to have a ROSS controller that handles all the topics and sensor messages and whatnot. And I'll write some type of controller package to run everything from. Currently, I'm in the process of getting the motors to actually communicate with the rest of the robot. So if we go over to the computer here, you can actually see sort of how this operates. I'm using Arduino ROSSerial. It's a controller for the Arduino that communicates with ROSS based on ROSS topics. You can see the terminal here. If I go ahead and enter in this command, you can actually notice, you may be able to hear that there's a motor that is turning here. It's turning very slowly, but we can actually adjust that and increase the speed slightly. So I'll go ahead and do that. So I'll make this something like, say, 80, I guess, would be good. And then you can see the robot here. It's actually rotating very slowly. I mean, it is stepper controlled, so it's relatively slow. Unless I change the speed, but since it's all wired up, it's not exactly a good idea to do that. There's a slight issue though with it. If I go ahead and turn this off real quick, and okay, and then go back to this, you'll actually notice that one of the motors actually does not work, and this is because the when running the robot, well, gosh, that makes a horrible racket. Let me turn that off real quick. When running the robot, there's a lot of current that's pulled because of the robot has gotten a little bit larger with all the different components added. So I had to increase the current going to the stepper drivers, and that has had the effect of heating up the motor substantially. So to remedy that, I'm going to replace some of the motors. These are the previous gearboxes that I was using. They're 3D printed gearboxes for the NEMA 17. They use a 16:1 reduction, but the new ones are a little bit chunkier. They are still a 16:1 reduction, but they have a little bit larger size and fully constrained bearings for them, and where did that go? And additionally, it uses a NEMA 23, which can provide a substantial amount more torque. I think it's about 1.3 to 0.3 Newton meters. So yeah, don't quote me on that, but a little bit substantial increase in the torque. So we'll see how that goes. Also, here is some footage of the new gearbox assembly. This uses a NEMA 23, which is the same motor that they used for the lower axis of a robotic arm I also designed. Some of you may be asking, why use steppers instead of brushless motors? The reason for this is simple. Steppers, while they require drivers, are a little bit more cost-effective than something like build-oriented controllers, such as O-Drive, that are commonly used with brushless motors. And since I also use steppers for the SCAR arm manipulator, I find it's best to keep the hardware the same on the entire robot. So if you like circuitry, 3D printing, engineering, science, and robotics, please like and subscribe, and have a wonderful day.